Buongiorno baddies, welcome back to new videos, problem number 22 of the 2025 AMC8. A classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced, so that there's the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose that there is at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? So this problem is basically kind of an algebraic solution type situation where you have to add in numbers. So basically, if we deem C as the amount of coats that are on all 35 hooks, and H as the amount of hooks before each coat. So for example, if you had this, then H would be this amount, and C would be this amount, and all the way up and up and up, like so. But H only accounts for this. So that means that if we deem H as such and C as the amount of coats on all 35 hooks, we can write an equation. C plus, since H is only the amount of hooks before every coat, and there are always one more gap of hooks than there are coats because the very last coat still has a couple empty hooks behind it, plus H multiplied by C plus 1 because there's always one more gap than there are coats. That means that this is equivalent to 35 because of all the 35 coat hangers. And you might say, okay, she's gone cuckoo again. What are we supposed to do with this situation? If you add 1 on both sides, you can notice now, and also just a very convenient number, you can notice now that we can pull out the C plus 1 and apply Simon's favorite factoring trick to it. So if we pull out the C plus 1, we basically get C plus 1 multiplied by H plus 1. How very nifty. Is equivalent to 36. However, once we get 36 is when things start to get a little bit more tedious because now we need to list out all the factors of 36 because we need to add them into the hook situation. And like I said, since there are always C plus 1 number of gaps, this means that a couple are also going to be taken out of the situationship. You'll know what I'm saying later. But basically, listing out all the factors of 36, we have 1, 2, 3, 4, no 5, yes 6, no 7, no 8, yes 9, no 10, no 11, there is 12, no 13, no 14, no 15, no 16, no 17, yes 18, and there's 36. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you might be like, okay, then it's answer choice E. But it's actually not, because there are a couple situationships in which this doesn't work. For example, if H was equivalent to the number of gaps here is equivalent to 1, that means that there would be no coats on the hooks. Because like I said, there is always one more gap than there are coats, and if the amount of gaps was 1, then there would be no coats. And that goes against what the problem is saying, and the problem in math is always utmost law. There's at least one coat and at least one empty hook, which means that 1 is not a viable solution for this problem. Similarly for 36, if there were 36 empty gaps, that would mean there are 35 coats. That means that the big bad coats take up the entire 35 hooks and leave no empty spaces in between, which also doesn't work because it says that there is at least one empty hook, which means that 36 is also not a viable solution. Which means we only have the 7 remaining numbers left, 2, 3, 4, 6, 9, 12, and 18. Seeing them, counting them up, we get 7, aka D. So yeah, that's the end of this video. Hope you guys enjoyed, and I'll see you all on the next one. Bye bye!